All right, good morning, good afternoon, or good evening, depending on when you're watching this video. So in this video, I will be going over the rest of the lab write-up, and I want to talk about calculations, data you've already done in your lab. So these are the points that you're going to get for the rest of your lab report. Now in lab, you saw me grade this parts. So that's what's going to happen every lab period. So here, the calculations, I'm going to go over what I'm expecting. The data, I've already checked you off in lab. So if you have my signatures on all the tables, so you have to make sure to include my signatures in order to get these points. All right, so then you'll get those points. I'm going to be checking for sig figs. I'll let you know where. And then here, the results and discussion. Now, this is going to be different than what's in your lab manual. So what I want you to do is go by this rubric. Okay, so this is not the same as the lab manual. Okay, so I want everybody to go by this instead. That's why I write the rubric and let you know what I will be looking for. All right, so let's start with calculations. What am I looking for? So here, I have some example data. Now in the lab, I mentioned write everything with, when we're in the lab, with pen, and it has to be with black or blue ink only. All right, so I'm going to go based off of just this part A, and then the rest of the tables will be similar. So what I want everyone to do for the calculation is to show me this. So you're going to title it, or you can type it, depends on what you want to do. So you'll have calculations, and then table 1. And then what I want to see here is, all right, your density calculation, just show me one. So the density here, and I'll do it for trial 1. And I'll go, okay, the density will be our mass, 19.9575 over our 20 mils. And that's going to give me 0.9979 grams per milliliter. Okay, so that's going to be one of our calculations. Make sure to check significant figures. Everyone should have 4 decimal places after the decimal place, or after the decimal, because you use the Chem 400 balances. So you don't have to show me all of the densities for each, but just show me one. And then what we're going to do, I want you to show me your average density. Okay, your average density. Because at this point, you should be working on this results table. All right, and we need the average density here. So I'm going to do this for this first column, and then you can do the rest. I'll explain ranking. Then after that, it should be pretty straightforward. So the average density, it'll be 0.9979 grams per mil plus 0.9916 grams per mil plus 0.9963 grams per mil, all divided by 3. Okay. Okay, and that's going to equal 0.997267, and we're just going to do, there's going to be 4 places after the decimal, 1, 2, 3, 4 here. So then our density will be 0.9973 grams per mil. All right, so there's our average. So that is what you're going to go ahead, and I'm going to flip this page. So I'm only doing this for table 1 so far. So I'm going to go back to where I fill it in our results table. And let me just write in the temperature. So the temperature I have for this pipette was 18 degrees Celsius. This correct density, I'll tell you where that is in a second. This average density, I'll put in here. So this is calculated. All right, okay, so let's go ahead and look for this correct density. So this correct density, let me find my paper here. It's going to be from this table in the lab. So let me show everyone this table. So here's the lab that we're using. And here is where you're going to find the correct density. So this is the correct density. And I had 18.0, so here's 18, here's 0.0. So I would use this value for this video. Now, if you were 21.5, then you go 21 and go over to 0.5, and that's what you would use. All right, but I'm going to go ahead and use this for mine, 0.998595. Use the whole number. You're going to use the whole entire number. So 0.998595 grams per mil. So you're going to use the whole value, whole number. Okay. All right. So now we have our temperature, the density, the average density. So percent error. So I talked about accuracy versus precision. So this is how we're going to determine our accuracy. Okay, so how close is our value to the true value? So let's go ahead and calculate that. So the next section, so let me box this. So the next section is going to be your percent error. Now, the formula for the percent error can be found in the back of your lab manual. So I want to show everyone where to find that. So if I look in the back of this lab manual, over here, this gives you accuracy error and percent error, so you could read more about that. And here is where you can find the standard deviation formula. So I will be using these. Okay, so the percent error is going to be our experimental value minus our accepted divided by our accepted times 100%. And this accepted is our correct density from the table. Okay. So let's take a look at this data. So my experimental is 0.9973 grams per mil. The accepted is 0.98595. So I'm going to do the numerator first, and this is because of significant figures. So this is where I'm going to check a lot for sig figs. So if I have 0.9973 and I subtract from 0.998595, I'm going to get minus 0.001295. So notice here, this has 1, 2, 3, 4 places after the decimal. It says more. So this has to have 1, 2, 3, 4. So I'm going to cut it off there. But I'm not going to round until the end. So then I have negative 0.001295. And remember, we cut it off here. Divided by the accepted again, 0.998595 times 100%. So that means when I'm done calculating this, I only have two significant figures. So this is going to be divided by 0.998595. And I get, don't forget to multiply by 100. I get negative 0.13%. Now, a negative number for a percent error, if you recall from a previous class, this just means that it's lower than the accepted value, and that's perfectly fine. Okay, so percent errors can be negative or positive. So then my percent error is going to be negative 0.13%. Okay, so here, be careful with sig figs. Okay. All right, now I'm going to leave the accuracy for last. Let's now go ahead, because this is just a ranking. Let's show standard deviation. So far in your calculation section, so you're going to have each table and then give me the density, the average density, the percent error, and then finally, let's do the standard deviation. Now you have to show me one calculation. So standard deviation. Now the standard deviation, this will show us how close our values are to one another, how close our measurements are. Now the formula that we use, our formula is going to be in our lab manual, is this version. Some of you have taken stats and there's different formulas. You're going to use this one. The sum of our first data point, or our data point, minus our average squared. Okay, so that means we're going to add up all of those. We're going to take the summation of that difference divided by, and this is under the square root, n minus 1. So I'm going to use our data to do that again. So if you, so here are my 3 values, and so then I'm just going to write a big square root right here to show everyone. And you only have to do this, just show me for one table. I don't need to see it for all of the tables. Okay, so here I'm going to go ahead and put the first data point, and I have my average here, so let's do that. That'll be a little bit easier. So I have my first data point here, 0.9979, subtract it from the average, 0.9973 squared, okay, plus the next one, 0.9916 minus our average, 0.9973 squared, plus, let's do another one, 0.9963 minus the average, 0.9973, all squared, all divided by n minus 1. Well, we have 3 minus 1. Okay, so then we'll go ahead and calculate that. Okay, so after, and then don't forget to take the square root. So the standard deviation is going to be plus or minus, and I got 0.004 for the standard deviation. So for standard deviation, it's always one significant figure. And the way you need to report this is you're going to report your average. So our average is 0.9973. And this is going to be plus or minus 0.004. Now, when you report your standard deviation and average, what you need to do, because I'm not going to put the units yet because I'm not finished. So if this has 3 decimal places after the decimal, this has to have 1, 2, 3 places after the decimal. So it's going to get cut off there. So then this is going to be 0.997 plus or minus 0.004 grams per milliliter. Okay, so that's what I want in the calculations page. So let's go ahead and look at your data tables. So for the standard deviation, what you need to put here is 0.004. Okay. All right, now at this point, you're done with your pipette table 1. So then you would go ahead and begin your table 2, and you would do the same thing. Okay, but I want to go over, so I'm going to let everyone do that on their own. If you have more questions, let me know, but I went through how to do all that, so I think we're good. If not, let me know as well. I could let you know more, but then the last part will be, so this is precision, how close the data values are together, your measurements. So now say we have an accuracy, say I'm just going to make up different percent errors. So let's see, I don't know, I want to make it kind of diverse. So let's say this one was like minus 7.2%, and then say this is like 0.79%. Okay. All right, so here we have our accuracy. So then how would we rank? Well, getting closest to 0 is the best. If you have 0% error, that means that your value is the same as the true value. But if we take a look here, don't get thrown off by the negative. Okay, so just look at the magnitude. So it just means it's lower than the true value. So here, if I have 7%, this must be the worst compared, right? So this would be the best, it's closest to 0. This is the next closest, this is the furthest away. So then I would rank this as third, being the least accurate. This is the most accurate, and then this is in the middle. Okay. Precision works similarly. So let me just make up some precision values. So I have 0.001 for this one, and say I have 0.02 for this one. You want it to be closest to 0. So if I'm looking at this, the one that's going to be closest to 0 will be this 0.001. So that means if you have 0 for your standard deviation, that means you got all of the same value for your measurements. So that's very, very precise. You're getting that same density each time. So it's possible to have a 0 here as well. Now, the one that's furthest away is this 0.02. So this precision for the beaker wasn't the best. So this would be third, and this would be second. Okay. All right, so then that's how you're going to go ahead and complete the table. Now, once you're done with the calculation portion, I'm finding my rubric here. Okay, let me get that back up. Once you're done with the calculations, then the next part of your lab report will be your results and discussion. So I'm going to check sig figs, especially on percent error and standard deviation. Okay, so that's where I'm going to look mostly for the first one, because I'm checking everything else in lab. Now for your results and discussion, all I need, it just needs to be short and concise. I just need a sentence on listing which glassware you found to be most accurate. This is spelled incorrectly. All right, so my discussion, if I were to write this, would be if I had to go from most accurate to least, then I would write, okay, the most accurate was the pipette. I would say I found that the most accurate piece of glassware is the pipette, followed by the burette, and then finally the beaker. And that's good. That's all you need for that sentence. Okay? And then do the same thing for precision. And then list sources of error. Now there's two types of error. There's random error and there's systematic error. So the type of error, it's really hard to determine random error. Okay, so we really don't speak to this very much. What we speak to is systematic error. So this one would be the balance drifting, right? So you can have instrumental error. Okay, so if it consistently goes down in value, that's an example. Another example in this lab, so you have to take a look at your data, but an example would be when you're pipetting, if you didn't get that to be the most accurate or precise, because really you should expect the burette and the pipette to be the most accurate pieces of glassware, most precise. It could be your skill level, aligning that meniscus isn't there yet. Reading the burette, okay, so if you could be reading your burette always a little bit on the low side. That's systematic error. We can tell where that comes from. In the conclusion, what I want you to answer, go back to your purpose. Did you meet the purpose? If you did, which everyone should have, I was in lab with you, you're going to give me your average percent error and your standard deviation for all three pieces of glassware. Okay, and then talk about any error that you have and how you can improve it. So any error you discussed here, how could you improve it the next time? And then finally, what new techniques did you learn? Okay, then after that, you're going to upload your report into Canvas. Okay, and you're going to have a PDF, and you need to include this rubric. All right, so hopefully that's going to be pretty clear for everyone. If you have any questions, please let me know.